morning and welcome to the viewers from India and abroad, especially the viewers from France who are watching this event live coming from the Mission Control Center at Sriharikota, the spaceport of India. Today, we have a very significant launch of Megatropic satellite, a joint endeavor of Indian Space Research Organization ISRO and the French National Space Agency CNES. Megatropic satellite is intended to study the water cycle and energy exchanges in the tropical region covering 20 degrees on either side of the equator. The launch of Megatropics will take place today at 1 minute past 11 hours Indian Standard Time on board India's Polar Satellite Launch Vehicle PSLV C-18. My name is Radhakrishnan and I have here with me my colleague Shri Madhav Dekne bringing to you live this important event. As you can see on the screen, the 45-meter tall PSLV vehicle is standing majestically at the first launch pad. In this mission, we have a total of 4 satellites, Megatropics, which is primarily a primary satellite, and 3 co-passenger satellites, namely SRM-SAT from SRM University, Chennai, Jugnu from Indian Institute of Technology, Kanpur, and VesselSat-1 from LuxSpace, Luxembourg. Today we have a little cloudy weather here, but everything is set for a very precise and successful mission. Just a quick recap. The 50 hours countdown for the PSLV C-18 mission commenced on 10th of October, that is day before yesterday at 9 hours Indian Standard Time. The countdown started following the clearance given by the Launch Authorization Board after reviewing various aspects of the readiness of vehicles, satellite, ground station and other ground systems. The launch window for today's launch will open at 1 minute past 11 hours and we have a total launch window of more than 60 minutes and we expect the liftoff to take place in about 27 minutes from now. The countdown is right now 27 minutes 50 seconds. Now I request my colleague Shri Madhav Dekne to continue in Hindi.
सुस्वागतम। आप सभी को सतीश धवन अंतरिक्ष केंद्र से माधव ढेकने का नमस्कार। मैं आज अपने सहयोगी श्री राधाकृष्णन के साथ PSLV C-18 मेगाट्रॉपिक के प्रक्षेपण के रोमांचक क्षणों को आप तक पहुंचाऊंगा। भारतीय अंतरिक्ष अनुसंधान संगठन इसरो और फ्रांस की नेशनल स्पेस एजेंसी CNES के सहयोग से बना हुआ मेगाट्रॉपिक उपग्रह आज की उड़ान की विशेषता है और इसके साथ साथ SRM विश्वविद्यालय का SRM-SAT, भारतीय प्रौद्योगिकी संस्थान IIT कानपुर के छात्रगणों द्वारा विकसित किया हुआ जुगनू और लग्जेमबर्ग की लक्सस्पेस का वेसलसैट, ये 3 छोटे उपग्रह भी कक्षा में स्थापित किए जाएंगे। PSLV प्रमोचन यान की पूरी तैयारी हो चुकी है। आज के मिशन की उल्टी गिनती 50 घंटे पूर्व सोमवार को सवेरे 9 बजे शुरू की गई। 44 मीटर ऊंचा और 228 टन वजन का PSLV रॉकेट श्रीहरिकोटा के प्रथम प्रमोचन मंच पर पूरी शान और गरिमा के साथ उड़ाने के तैयार है। इस समय यहाँ मौसम अच्छा है और उड़ान के लिए अनुकूल है। आसमान में थोड़े बादल दिखाई दे रहे हैं, लेकिन चिंता की कोई बात नहीं। उड़ान के लिए सतह पर 15 मीटर प्रति सेकंड तक वायु वेग की मर्यादा होती है और 20 किलोमीटर की ऊंचाई तक का वायु वेग का विश्लेषण भी महत्वपूर्ण रहता है। पूरे अभ्यास के बाद उपग्रह प्रक्षेपण का समय 11:01 पर निश्चित किया हुआ है और अब हम उड़ान से करीब 25 मिनट की दूरी पर हैं।
The countdown is now minus 25 minutes and this is a view of the mission control centers. We have some of the very important and senior dignitaries who are present here for witnessing the launch. We have Dr. K. Kasturi Rangan, Member Planning Commission, Professor MGK Menon, Professor MGK Menon, Sir Shailesh Nayak, and some of the very senior dignitaries who are present here. We also have with us some of the French delegation who are representing the megatropic satellite. This is a view of the Mission Control Center. Now we'll bring to you a short pre-recorded documentary depicting the making of megatropic satellite, which is a joint Indo-French mission. The documentary will highlight the various aspects of applications and services the satellite will render to the nation and the international community in the coming years. I request the producer to play the documentary.
In an awesome display of nature's splendor, the rolling clouds, the megha, reach down from the sky to embrace the earth and shower it with rain. This deep, amorous relationship between the megha and the earth results in making the earth fertile and fruitful. For ages, man has tried to understand this natural phenomenon in all its intricate detail. This natural precipitation, which pours down from the clouds in the form of rain, is the lifeline of mankind. Many years ago, the great Indian poet Kalidas sang about this in his famous poem Meghdutam. The fate of the people of India depends mainly on the nectar which is showered from heaven by the cloud. Today, the scientists are romancing the cloud. It is the need of the hour to find out and understand the characteristics of the water cycle and the parameters that affect it and obtain significant statistics for analysis. As we all know, the water cycle in general is driven by the thermal energy received from the sun. The exchange of this energy among the oceans, the land and the atmosphere controls global climate. Tropical areas receive most of the sun's energy and send water into the atmosphere by the process of evaporation. However, at present, we have limited scientific understanding of the global and local parameters and processes which affect the water cycle. Because of this, we are not able to have clarity in our predictions about climatic events like cyclones, monsoons, floods, or droughts in the tropical zone. This is why investigating the climate to study the energy budget in this part of the globe has become a priority.
India has a vibrant and multi-dimensional space program. It has been unique in a sense that people-centric space applications and space-based services have been the bedrock on which it was conceived and been progressing. We are embarking on new vistas in this direction. Improving the understanding of climate and weather systems is of paramount significance for a monsoon-dependent agrarian economy like India that also goes through the vagaries of cyclones and drought frequently.
A unique Indo-French scientific megatropic satellite has been developed specifically for atmospheric research. The data collected by the satellite will allow us to improve our knowledge of the contribution of the water cycle to climate dynamics in the tropical atmosphere, as well as increase scientific understanding of the process linked to tropical convection. This knowledge will enable us to predict short-term and long-term weather with a greater measure of certainty.
Considering that it is critical for India not only in the context of atmospheric science, but in a long-term perspective, this aspect can also tell upon our ability to make more precise predictions of the monsoonal system and also severe storm systems like the tropical cyclones. We decided that can we explore this area as the basis for looking into a flagship cooperation program. So both the sides got together. From our side, it was Professor Narasimha, who led the team of the atmospheric scientists, meteorologists, space scientists, and many other institutions where the atmospheric research were going on. They led the team of that. From their side, the Center for Atmospheric Research of France, the professors working there and the academics, they came together and worked with us, started interacting with us, and between them they started looking into what is the possible way to do this.
This satellite, thinking about it, started in many different ways. I remember in particular a meeting with Professor Sadoni, who came to my office and said, I hear that you people are thinking about a satellite for the tropics. I have a radiation sensor. Would we be able to put that radiation sensor on your satellite? Well, not only did we say we would be very happy to, but it turned out later on that the French were very happy to collaborate with us. We made considerable progress some 7-8 years ago, but then there was a major review in France which hindered our progress for a couple of years. We were very happy when at the end of that review, the French decided that this was one of the projects that should survive. So we now have a project which finally got the approval from the French and from our own Space Research Organization in India here.
The Megatropic spacecraft is cuboid in shape and has a dry mass of about 865.96 kgs, going up to 1000 kgs with fuel. A 3-axis stabilized spacecraft, its orientation control and high attitude stability is ensured by its electronic brain called the OBC, On-Board Controller, with the help of sensors, gyros and a propulsion system. 2 solar panels will generate a maximum of 2000 watts of electrical power. The rechargeable battery fitted in it is also capable of providing 1325 watts of power during the eclipse period. ISRO's lead center, ISRO Satellite Center ISAC, for developing spacecraft technology, has designed and integrated the Megatropic satellite.
And we have the joint science teams, both from France as well as within India. The joint working area is further developed into a global mission. So we have more than 30 groups working around the globe besides the French scientists. The scientists working include the US scientists, Japanese scientists and other scientists from other countries. All of them work together. We have a large number of scientists working from all the institutions. It is one of the wonderful experience working in the international program, and one of the excellent demonstration how ISRO can work in a productive way with the other agencies.
The Megatropic spacecraft has 4 scientific instruments seated on it. The main payload, microwave analysis detection of rain and atmospheric structures with the acronym MADRAS, has been jointly developed by the Space Application Center of ISRO and Centre National d'Études Spatiales CNES of France, and is an outstanding example of international cooperation and exchange of scientific knowledge. It is a 5-frequency conical scanning passive microwave radiometer providing brightness temperature measurements. The radiometer is designed to estimate rainfall, atmospheric water parameters and ocean surface winds in the equatorial belt. Sonde atmosphérique de profil de humidité intertropicale par radiométrie SAFIR is a multi-channel, cross-track millimeter wave humidity sounder for the vertical profiling of humidity in the atmosphere up to a height of 12 kilometers. This payload has been developed by CNES. Scanner for Radiative Budget, SCARAB, is a cross-track scanning optical radiometer featuring 4 channels for measuring the Earth's radiation budget. Channels 2 and 4 are considered to be the main channels, with the other 2 serving as auxiliary channels. This instrument has also been developed by CNES. The GPS radio occultation sensor enables measurement of water vapor and temperature profiles in the tropics. In addition, this payload will supplement the mission for atmospheric studies. The GPS ROS payload is configured as the 4th payload. Initially, the mission was studied within the framework of the small satellite program. Specific constraints on the weight of the payload, the available power and the data rate were induced. Further sharing arrangements led to the choice of an Indian IRS platform, which gives more margins in terms of the mass of the payload and available power. The majority shield of the PSLV C-18 awaiting liftoff. With the support of these 4 payloads, Mega Tropics will move in the low Earth orbit, LEO. This satellite, with low inclinations of 20 degrees, will provide high repetitivity with typically 6 observations per day at the equator and at the Intertropical Convergence Zone, ITCZ. The most energetic tropical systems, such as the cloud clusters of the ITCZ, the monsoon systems, and tropical cyclones, extend over hundreds of kilometers. Hence, a ground resolution of about 10 kilometers is adequate for these observations. India's most reliable polar satellite launch vehicle, PSLV C-18, has been chosen to inject megatropics to its planned destination of a 886-kilometer circular orbit. Megatropics will also have 3 co-passengers, VesselSat, Jugnu and SRM-SAT on board the PSLV. All post-launch operations will be coordinated by ISRO Telemetry, Tracking and Command Network ISTRAC Bangalore. The existing network of ISTRAC ground stations, along with support from agencies of other nations, will track and communicate with Megatropic under the control of Spacecraft Control Center SCC at ISTRAC Bangalore. The ground segment elements for Megatropics include SCC at ISTRAC Bangalore for payload data reception, data processing and data dissemination to MOSDAC, SAC Ahmedabad and CNES, France. Development of spacecraft health monitoring software, flight dynamic software and mission management will be done at ISAC, Bangalore.
Megatropics is considered as one of the first contributions to the constellation of satellites called Global Precipitation Measurements, evolved and initiated by NASA and JAXA, the Japanese space agencies. There are more than 20 principal investigators from international scientific organizations, as well as a similar number from the Indian scientific community, besides ISRO and CNES, the French space agency, who would be analyzing this in the initial stages and are part of the science working group.
The level 0 and level 1 data processing of Megatropics will be done at ISRO, Bailalu near Bangalore. Data products will be further transmitted to CNES France and MOSDAC, SAC Ahmedabad for further process and dissemination.
The data of Megatropic are now waited impatiently by all the scientific communities about meteo and climate. These data are very, very important, and we were asked by NASA and JAXA to have exchanges between Megatropic and the GPM mission, which is Global Precipitation Measurement, because we need to measure all around the world and with repeated measurements. So we need several satellites. And so Megatropic and GPM mission will join to be one constellation, bringing new data, very precious, to the scientific communities.
There are more than 20 teams of scientists waiting all over the world to receive these data for further scientific use. Mega Tropics, a bilateral mission between ISRO and CNES, marks the availability of a unique combination of sensors, providing an opportunity for the global Earth observation community to use the garnered information along with other international contemporary satellite systems.
Welcome back. Welcome back to the live transmission from the Mission Control Center. We are at minus 9 minutes for the launch. So view of the Mission Control Center. So we are at 8 minutes 57 seconds. A quick summary of the events that has happened during the pre-recorded capsule that was played for you. At T-minus 15 minutes, the mission director has given the authorization to proceed with the launch. This authorization is based on the readiness of the various vehicle level systems, satellite, range, and telemetry. At T-minus 14 minutes, the vehicle director has authorized the initiation of the automatic launch sequence, ALS. Once the ALS program is initiated from this event onwards, all the vehicle and satellite related activities are taken care by the onboard computer, including all decision making and command execution. As we can see on the screen, the countdown is at 8 minutes.
अभी रॉकेट, उपग्रह, भूकेंद्र, दूरमिति प्रणाली इत्यादि के पूरे जांच के बाद प्रमोचन प्राधिकरण बोर्ड व मिशन निदेशक ने उड़ान की अनुमति दे दी है और ऑटोमेटिक लॉन्च सीक्वेंस शुरू हो चुका है और अब हम उड़ान के नज़दीक पहुंच रहे हैं। सभी विशेषज्ञ रॉकेट संबंधी आंकड़ों पर नज़र रखे हुए हैं।
The countdown is 7 minutes 26 seconds. Another 7 minutes to go for the launch. It's a view of the Mission Control Center. We have, in the meanwhile, we have a very brief video capsule bringing out the glimpses of the PSLV C-18 launch vehicle and satellite integration activities. The launch campaign for the mission commenced on August 14.
Unique and innovative compared to earlier eastward missions.
This is what you see on the screen is the movement of the first vehicle hardware. The core pressure out in the nozzle end segment is being moved to the first launch pad, and the lifting of the first segment of the hardware. This particular activity took place on August 14. You can see the movement of the first segment being placed inside the launch pedestal. So the first stage of the rocket basically has 5 segments. Once fully integrated, the total amount of propellant that it carries is around 139 tons. So you can see the 5 segments getting mated with each other. So first stage PS1, S139 stage is fully integrated, and this is the assembly of the igniter, which basically initiates the combustion in the solid rocket motor. This is the interstage hardware, which is basically used for connecting the next stage to the first stage, interstage 1/12.
अभी हम रॉकेट के दूसरे चरण के इंटीग्रेशन को देख लेते हैं। रॉकेट का दूसरा चरण, इसमें द्रव प्रणाली उपयोग में लाई गई है। 40 टन वाले इस चरण से करीब 6.10 किलोमीटर प्रति सेकंड की गति रॉकेट को मिलती है और लगभग 150 के सेकंड से इस ज्वलन से रॉकेट 172 किलोमीटर ऊंचाई पर पहुंच जाता है। इस स्टेज का इंटीग्रेशन 5 सितंबर से शुरू किया गया था। अब हम देख रहे हैं तीसरे और चौथे स्टेज का इंटीग्रेशन।
So the third and fourth stage, third stage is a solid stage with 7 tons of propellant loading, and the fourth stage is a liquid stage with 800 kg of propellant. What you see now is the megatropics with the payload adapter underneath getting mated to the fourth stage. If you look at the level at which this particular activity is taking place, it is
the weather temperature is rising in the global scale or they are reducing, or whether the ice is melting or accumulating. This is called global water and mass balance. This kind of questions can be probably understood and answered through this mission.
So this is the integration of the vessel sat. So we have all the 4 satellites mated to the launcher. The integration of the satellite took place from September 29 to October 2nd, and the closure of the payload fairing with the spacecraft inside, this particular activity took place on October 3rd.
Stringent mission specifications, and we have got a ground model which is now for the past 3 years it is in the life test, and we are very confident that this payload will function and provide the data to the intended mission.
The vehicle fully assembled. You can see a long shot of the PSLV C-18 vehicle. The mobile service tower has been moved back, and the countdown is minus 2 minutes 50 seconds. So today's PSLV C-18 vehicle is a core alone configuration which does not use the 6 solid strap-on in this particular configuration. And this configuration of PSLV has been flown several times on earlier occasions. PSLV is primarily a 4-stage vehicle where the first stage is a solid stage, the second stage is a liquid stage with 40 tons of propellant loading. The third stage is a solid stage again with 7 tons of propellant loading. And the upper stage is a liquid stage with 0.8 tons of propellant loading. If you look at the overall mass of the launch vehicle at the launch pad at the time of liftoff, it's 230 tons. So PSLV will place Megatropics and other co-passenger satellites in a circular orbit of around 867 kilometers above the Earth, and the orbit in its final configuration will be inclined at an angle of 20 degrees with respect to the equator.
उल्टी गिनती शुरू होने के से अब तक 700 में से 620 कार्यवाहियां पूरी कर ली गई हैं और बाकी 80 गतिविधियों को भी पूर्व निर्धारित पद्धति द्वारा समय पर पूरी कर ली जाएंगी। अब हम करीब 1 मिनट 25 सेकंड दूरी पर हैं। यू कैन सी आवर चेयरमैन डॉक्टर राधाकृष्णन,
View of the Mission Control Center, Chairman ISRO, Dr. K. Radhakrishnan, Shri Dattan, Director Satish Dhawan Space Center, Shri Veer Raghavan, Director Vikram Swaraj Space Center. Now countdown is at 55 seconds. A few seconds away from the vehicle liftoff. So minus 40 seconds.
अब हम प्रथम चरण का क्लोजअप देख रहे हैं। उड़ान के लिए 25 सेकंड.
So we are at minus 20 seconds. A close-up view of the. We await the ignition of the RCT, reaction control thrusters, followed by the ignition of the solid stage. 7, 6, 5. RCT ignition. First stage ignited. Beautiful liftoff of PSLV.
प्रथम चरण की मुख्य मोटर प्रज्वलित हो चुकी है और PSLV शानदार तरीके से आकाश की ओर बढ़ता जा रहा है.
The PSLV blazing through the sky. So we are at 40 seconds into the flight.
रॉकेट अब ध्वनि अवरोध पार कर चुका है और रॉकेट की गति करीब 400 मीटर प्रति सेकंड है.
The first stage is expected to burn for 100 seconds. Just now we heard the announcement, the PS1 stage performance normal.
बहुत ही बढ़िया प्रक्षेपण.
So you can see the display, the time versus altitude. We are at 80 seconds.
प्रथम चरण का कार्यकाल लगभग समाप्त होने वाला है.
So we are at 100 seconds. A very beautiful view of the first stage thrusting. So we have the confirmation PS1 has been separated at 115 seconds and the second stage got ignited 115.8 seconds.
PS2 performance normal.
So PS2 performance normal.
दूसरे चरण का परफॉर्मेंस बहुत ही शानदार रहा है और रॉकेट आगे बढ़ रहा है.
So you can see the two plots. The top one is the velocity with respect to the time, and the bottom curve shows the altitude build-up as a function of time. So very close match with the pre-flight. The next event that we await is the separation of the heat shield at around 182 seconds.
रॉकेट के ऊपरी भाग में स्थित ऊष्मा कवच चारों उपग्रहों की रक्षा करता है.
Heat shield has been separated.
इसका विमोचन बहुत ही सफल रहा है. इस समय यान घनिष्ठ वायुमंडल से बाहर निकल चुका है.
The second stage with 40 tons of propellant is expected to burn for 148 seconds after its ignition. So the nominal time at the end of burnout of the PS2 will be around 262 seconds when the vehicle would have reached an altitude of 170. Right now the vehicle is at an altitude of 145 kilometers and the velocity is around 2.9 kilometers per second.
आप जो आलेख देख रहे हैं वह रॉकेट की अवकाश में ऊंचाई दिखा रहा है. सारे वैज्ञानिक उत्कंठापूर्वक सभी आंकड़ों पर ध्यान देते हुए.
So another 20 seconds to go before the PS2 burnout. The performance has been normal.
रॉकेट करीब 170 किलोमीटर ऊंचाई पर पहुंच गया है.
So The second stage got separated from the third stage at 264 seconds, and we have a successful ignition of the third stage, which is a solid stage at 266.2 seconds. And just now we have the confirmation the performance of the PS3 stage is normal.
PSLV का तीसरा चरण शुरू हो चुका है। परफॉर्मेंस नॉर्मल है। वेलोसिटी
So we are in the third stage flight. The third stage with 7 tons of propellant burns for nearly 107 seconds. The nominal time at which the PS3 will burn out is around 387 seconds. Right now we are at 320 seconds with 5 km per second velocity that has been imparted by the first two stages and the third stage. If you look at the range from the Sriharikota, the vehicle has traveled almost a distance of 680 kilometers. And the vehicle altitude right now is 210 kilometers.
आप जो डाटा देख रहे हैं वो सभी भू केंद्रों से यानी कि शार, अंडमान निकोबार, ब्रुनेई, बियाक इस सभी स्टेशन से प्राप्त हो रहा है।
So 364 seconds, 225 kilometer altitude. And shortly we will have the confirmation about the burnout of the third stage. The third stage, being a solid stage, it takes a little time for the thrust to drop down to a very safe and acceptable limit before it is separated from the ongoing fourth stage. This is basically done to prevent the catch-up of the lower stages with the ongoing stage. So after the burnout of the third stage, there will be little time of over 100 seconds before the third stage gets separated from the fourth stage. So right now we are at 400 seconds, 263 kilometers altitude.
तीसरे चरण के ज्वलन का समय बिल्कुल समाप्त हो गया है।
The nominal time of PS3 separation is around 520 seconds. Very anxious looking faces in the mission control center. You can please put up the view of the display plots. Display plots, please. 466 seconds. The velocity is around 7.16 and the vehicle is at an altitude around 330 kilometers.
कुछ ही क्षणों में PS3 यानी तीसरा चरण मुख्य रॉकेट से सेपरेट हो जाएगा, उसका विमोचन हो जाएगा।
495, 354 kilometers, 357 seconds. So very close match between the prediction that has been made before the launch and the actual performance of these stages. So the top plot shows the velocity. So we just now got a confirmation the PS3 stage has been separated. Now the PS4 stage along with the 4 spacecraft on top of it is going in a coasting phase. Coasting phase is the period of flight where there is no ignition or no propulsion activity of the rocket motor that happens. So if you look at in this mission, there is a long coast of about 800 seconds between third and fourth stage of the vehicle. This is primarily decided by the mission requirements to optimally meet the target conditions. So during the coasting phase of flight, the rocket motors are in off condition. At the end of the coast period, the fourth stage will get ignited at around 1167 seconds. As I have mentioned earlier, the fourth stage carries 800 kg of propellant, and the amount of time it is going to burn in flight will be roughly around 150 seconds. And at the end of the fourth stage burnout, it would have imparted a velocity of around 7.4 km per second to the vehicle.
अभी एक काफ़ी लंबा सा कोर्स ड्यूरेशन है। PS3 यानी तीसरा चरण सेपरेट हो चुका है और चौथा चरण शुरू होने से पहले अभी करीब 700 सेकंड की दूरी बाकी है। ट्रैजेक्टरी का ठीक तरह से डिज़ाइन करने के लिए इस कोस्ट की बहुत आवश्यकता थी और इसके बाद करीब अभी 650 सेकंड में चौथा चरण इग्नाइट हो जाएगा।
Yeah, the time is now 640 seconds, and vehicle is reached an altitude of around 488 seconds. Velocity that is that the upper stage and satellite are having is around 6.9. You can see there is a little drop in the velocity, primarily because there is no thrusting of the rocket that is taking place. This is a phase where the fourth stage is going without any propulsion, and after reaching a pre-specified target, the fourth stage will get ignited, and then it will continue to burn for 150 seconds. Now we bring to you a very short animation of how the various stages of the rocket get separated from each other before it injects the satellite into an orbit. So we are at 690 seconds, 530 kilometer altitude. So this is a small animation for you, just to give an idea how the stage separates. So this is a colon configuration. The first stage is separated from the second stage. And then we have a separation of the heat shield, which encapsulates the satellite. And then we have the separation of the second and third stage, followed by the last phase of flight, which is the ignition of the fourth stage. What you see on the screen is the ignition of the fourth stage, and then finally this separation of the spacecraft from the upper stage of the rocket. Yeah. So now we have a separation of the megatropics, followed by the separation of the, the time is now 747 seconds, and the vehicle is at an altitude around 580 kilometers. So as I was mentioning, the first satellite that will get separated after reaching the target conditions will be megatropics. This will be followed by separation of SRM sat, followed by Vessel sat, and the Jugnu satellite from IIT Kanpur. So the time is 773 seconds, altitude of around 600 kilometers. The nominal time at which the PS4 should ignite is 1152 seconds.
रॉकेट अपने मार्ग पर ठीक तरह से चल रहा है। उसकी गति अभी धीमी है और उसी गति से ऊंचाई पर जा रहा है।
Another 350 seconds to go before we have the ignition of the upper stage. A quick statistics of the launches that we have performed so far. So far, a total of 32 launches of various satellite launch vehicles of ISRO have taken place from here at the same spaceport Sriharikota. And over the years, we have developed the fourth generation of launch vehicles, namely SLV-3 and Satellite Launch Vehicle 3, ASLV and PSLV, followed by the Geosynchronous Satellite Launch Vehicle GSLV. So today's launch of PSLV C-18 is the 33rd launch that is taking place from the spaceport. And as you can see on your screen, and the time is 850, and the vehicle, as the velocity is reducing because there is no addition of velocity taking place from the upper stage, but the vehicle is gaining altitude. This is basically the conversion of the gaining of the potential energy at the cost of kinetic energy. 872 seconds, 680 kilometers. And at PS4 ignition, we expect the nominal altitude of the vehicle to be around 834 kilometers. Coming back, PSLV and GSLV are the operational launch vehicle systems of Indian Space Research Organization. And PSLV is the workhorse launch vehicle with 18 consecutively successful flights.
Plus 15 minutes. जैसा कि आप जानते हैं, इसरो की शुरुआत 1960 के दशक में हुई। प्रमुख उद्देश्य था अंतरिक्ष विज्ञान में अपने बल पर प्रमोचनयान और उपग्रह का निर्माण करना। आज तक श्रीहरिकोटा में कोटा से भारत के पूर्व तट स्थित इस द्वीप से भारत ने 32 रॉकेट छोड़े हैं, जिसमें 4 प्रकार के रॉकेट्स SLV-3, ASLV, PSLV और GSLV शामिल हैं। आज की ये 33वीं उड़ान है और PSLV प्रमोचन यान द्वारा भारतीय उपग्रहों के साथ साथ अंतर्राष्ट्रीय समुदाय के 26 उपग्रह हम आज तक सफलतापूर्वक अंतरिक्ष में छोड़े हैं। आपको याद होगा कि 2008 अक्टूबर में चांद्रयान 1 का प्रक्षेपण किया गया था और गर्व की बात यह है कि चांद्रयान की उपकरणों द्वारा चंद्रमा पर पानी होने का ठोस आधार भी हमें मिला था। अंतर्राष्ट्रीय स्तर पर यह एक बहुत बड़ी उपलब्धि मानी जाती है।
Now we are at 970 seconds. It is almost 16 minutes, 15 seconds since the liftoff at the opening of the launch window at 1 minute past 11 hours. Now we are at 990 seconds, 764 kilometer altitude, and the vehicle is with a velocity of 6.63 kilometers. And if we look at the range, this upper stage with the spacecraft has traveled from the launch base is nearly 4,900 kilometers. So we're into 50 seconds past 16 minutes. And wait another 150 seconds before the ignition of the 4th stage takes place. The upper stage will primarily impart the required velocity for placing the spacecraft in an altitude of around 867 kilometers, where the vehicle velocity requirement will be to the extent of 7.4 kilometers per second. So 790 kilometers, 1035 seconds.
अभी हम PS4 के इग्निशन के पास आ रहे हैं। उसके पहले मेगा ट्रॉपिक उपग्रह के बारे में थोड़ा बता दें कि वातावरण में होने वाले बदलाव का विषुववृत्तीय प्रदेश के मौसम और मेघावरण पर होने वाला असर, इसका अभ्यास इस उपग्रह द्वारा किया जाएगा। इसके लिए विषुववृत्त से 20 अंशों का कोण करती हुई 865 किलोमीटर ऊंचाई की कक्षा निश्चित की गई है। यह कक्षा अंतर्वृत्तीय अभिसरण खंड का पुनः पुनः अवलोकन करने का अवसर देती है और यह मिशन जल संतुलन चक्र और ऊर्जा विनिमय का अभ्यास करने के लिए बहुत ही उपयुक्त होगा। और इसमें 4 प्रमुख प्रयोग उपकरण होंगे: मद्रास, साफिर, स्कैरब और रोजा।
We are at 18 minutes, 17 seconds. PS4 ignited. And just now we got the confirmation PS4 is ignited.
PS4 का सफलतापूर्वक।
We expect PS4 to burn for 154 seconds. So time is 1123 seconds. 844, and you can see the build-up in the velocity. Now that the rocket stage is ignited, you will see the continuous increase in the vehicle velocity.
19 minutes. चौथे चरण का ज्वलन शुरू हो गया है और रॉकेट ठीक तरह से आगे बढ़ता हुआ।
So PS4 in its ignition phase. The vehicle velocity is around 6.6 kilometer per second. And the range is around 5,900 kilometers.
करीब 860 किलोमीटर ऊंचाई पर अब सैटेलाइट और प्रक्षेपण यान पहुंच गए हैं.
PS4 performance normal.
So PS4 performance is normal.
Plus 20 minutes.
PS4 का परफॉर्मेंस बहुत ही शानदार रहा है.
(1,200 seconds). The velocity is 6.77. So after the target conditions are met, the upper stage will get cut off, and then the separation of the megatropics will be taken off. So we are 1,225 seconds with 6.8 kilometer velocity, and the vehicle has almost reached its altitude of 865 kilometers.
आप देख रहे हैं कि अब ये पूरे कक्षा में बहुत ही नज़दीक पहुंच गया है. करीब 0.5 किलोमीटर पर सेकंड की दूरी तय करनी है.
1,251 seconds. The velocity is 6.9 relative velocity, and we await the separation of the megatropics first. So around 57 seconds after the cutoff, we have the megatropic satellite has been separated from this space PS4
बहुत ही
stage.
शानदार प्रदर्शन. तालियां गूंजती रही है.
The megatropic satellite successfully separated at 1,288 seconds.
एक प्रमुख सैटेलाइट सेपरेट होने से बहुत बड़ी उपलब्धि हमने प्राप्त कर ली है, और आगे 3 छोटे-छोटे सैटेलाइट्स को सेपरेट करना है.
Now you can see a very good orbit that has been achieved, 866 by 864 kilometer and an inclination of 20 degrees. This is what was desired from the PSLV C-18 mission, and we await the separation of the SRM sat, which should take place in another few seconds from now.
SRM सैट, वेसल सैट और जुगनू, ये 3 सैटेलाइट अभी इसी क्रम में सेपरेट हो जाएंगे.
And this, we got the confirmation of the separation of the SRM sat from the upper stage. A very joyous moment in the mission control center. So SRM sat has been successfully separated. SRM sat is primarily an 11 kg satellite built by SRM University Chennai, mainly meant for monitoring the atmospheric parameters. And the next event that is going to come up is the separation of the vessel SAT-1, which is an automatic identification system for monitoring of ships, basically developed by Luxembourg.
अब हम वेसल सैट की सेपरेशन की प्रतीक्षा में है. करीब 29 किलोग्राम का ये माइक्रो सैटेलाइट लक्सेमबर्ग ने बनाया है, और इनमें समुद्री जहाज से भेजे गए संदेश पकड़ने के लिए उपकरण लगाए गए हैं.
So vessel sat will be separated shortly.
Plus 24 minutes.
We are almost 24 minutes since the liftoff. After the separation of the vessel sat, will be separation of the Jugnu spacecraft. So vessel sat 1 has been successfully separated from the upper stage. at 1458 seconds.
वेसल सैट सेपरेट हो चुका है और 3 किलोग्राम वजन का जुगनू, जिसे नैनो सैटेलाइट कहा जा सकता है, उसके सेपरेशन की प्रतीक्षा में हैं हम। आईआईटी कानपुर के विद्यार्थी तथा अध्यापक वर्ग की ये बड़ी उपलब्धि है। इसमें लगाए गए स्वदेशी इंफ्रारेड कैमरा से जंगलों का विस्तार और जलाशयों का पता लगाया जा सकता है। इस प्रोजेक्ट की विशेषता यह भी है कि अत्यंत जटिल और महत्वपूर्ण उपग्रह की विमोचन प्रणाली भी आईआईटी के छात्रों ने ही बनाई हुई है।
We await the separation of the Jugnu spacecraft. The Jugnu nano satellite and Jugnu has been separated. So we have all the 4 spacecraft successfully separated from the upper stage. A very happy moment here in the Mission Control Center at Sriharikota. You can see Chairman ISRO.
बहुत ही उल्लास दिखाई दे रहा है यहाँ पर।
A very happy moment here. And this is the 3rd successful launch of PSLV during this year of 2011.
चेयरमैन
In
डायरेक्टर
a
VSSC
few minutes from now, we will be having the address by some of the senior dignitaries of ISRO, Chairman ISRO, followed by some of these other senior dignitaries who are present here. You can see the view of the Mission Control Center, Chairman ISRO, greeting.
इस मिशन की तैयारी में इसरो, सीएनएस, लक्सपेस तथा आईआईटी कानपुर व एसआर यूनिवर्सिटी के विद्यार्थी वर्ग ने अपना पूरा सहयोग दिया है।
A very happy moment, Dr. Kasturi Rangan.
हम सभी का हार्दिक अभिनंदन करते हैं। बहुत ही सक्सेसफुल, बहुत ही सफलतापूर्वक ये प्रक्षेपण सिद्ध हुआ है। आप देख रहे हैं डॉक्टर एमजी के मेनन, डॉक्टर कस्तूरी रंगन।
In a few minutes from now, we should have the address by Chairman ISRO, who will be congratulating and addressing the entire ISRO community and the nation.
एक बहुत ही महत्वपूर्ण मिशन में हमने सफलता हासिल की है। सभी को बधाई।
So now the view of the mission control centers will be addressed by Chairman ISRO.
The PSLV C-18 flight has been a grand success. Very precisely, 4 satellites were injected into a circular orbit, and the difference between what we planned and what we achieved is just 2 kilometers over an altitude of 867. We have the Megatropic satellite, which is a joint Indo-French mission. And we have 3 co-passenger satellites made by SRM University, Chennai, IIT Kanpur, and from Lux Space of Luxembourg. I have with me one of the founding fathers of ISRO, Professor M.G.K. Menon, 2 great scientists who conceived in the late 90s the need for a Megatropics mission, Dr. Kasturi Rangan and Professor Narasimha. And we also have the director of the French Space Agency with us. And we also have the leaders of the ISRO family, all members of the ISRO family present here. I would request Dr. Kasturi Rangan to say a few words, followed by Professor Narasimha, Professor Menon, and Director CNES.
First of all, hearty congratulations to you, Dr. Radhakrishnan, and the entire team that today we witnessed as a successful mission of Megatropics and other satellites. Certainly, the entire team deserves kudos from every one of us, and I represent this time the Planning Commission, and therefore on behalf of the Planning Commission and its Deputy Chairman, Dr. Montek Singh Alwalia, I would like to extend to all of you our own greetings in this very happy and memorable time. I don't have to say much about the PSLV. It has become synonymous, this name, with the perfection in launch and space transportation. It has evolved over years, but today you witnessed one more of its consistent performance with respect to putting satellites, multiple satellites, into the orbit. Well, Megatropics and all the other satellites are in their own way very unique, and I particularly would like to say Megatropic opens up a new era of atmospheric research, especially in the tropical weather system. I know ISRO has got a very, very important agenda ahead of them, not only in launching the RESATs and other kinds of satellites, but more importantly, completion of the developmental phase of the GSLV Mark II, and also the rapid strides that they are making in the context of the Mark III. So on behalf of all of you, on my behalf, and on behalf of the Planning Commission, I would like to extend not only our greetings on this very happy occasion, but also wish them the very best in the immediate missions of the future, and also their long-term perspective of taking this program to higher heights and higher levels. Thank you very much.
Well, let me first of all once again congratulate Dr. Radhakrishnan and all his colleagues in all the ISRO centers who have made this magnificent mission possible. On behalf of the scientific community, especially in the atmospheric sciences and meteorology, I want to thank ISRO, its current chairman and the previous chairman, Dr. Kasturi Rangan and Dr. Naya, for the way that this project has been pursued over the last 10 years. And thank also our French colleagues for staying the course and for making it possible to launch a landmark mission in the history of atmospheric sciences in India, but I think also in the world. Because this is only the second satellite which is, whose focus is on the tropics. We live in the tropics, and whether it's the monsoons or whether it's climate change, clouds play a big role, convective systems play a big role. So this satellite is first of all going to give us exciting science, but it will also be something which will be very useful to society and to our nation and to the world. And thank you all very much once again.
It's a great pleasure to be at the Satish Dhawan Space Center, Shah, to watch the launching of something he had always dreamt of, which Dr. Kasturi spoke about, the PSLV on a mission. And in this particular case, the mission involved a French satellite, an Indo-French satellite. I am delighted to be here partly because we have used French Guiana and Kourou for the launches of many of our satellites on the Ariane system. And today we have, in contrast, the launch of the Megatropics from Sriharikota, the Satish Dhawan Center. So I would like to congratulate Dr. Radhakrishnan, all of his colleagues who are here, whom I have known for many, many years, for the great success that they have achieved in this launch. Congratulations once again, not only for their success, but for their future. Thank you.
We have with us the Mission Director, Mr. Kunjikrishnan, and Mr. Raju, the Project Director of Megatropics.
Good morning. nothing succeeds like a success, but maintaining and sustaining the success is the difficult task. Today we have done it by soaring to its predetermined destination, following precisely the intended trajectory, and finally injecting all the 4 spacecrafts into the desired orbit. PSLV C-18 has added yet another glorious chapter to the history of Indian space program. Today, we have seen the reliability and versatility of PSLV launch. Like our earlier missions, the PSLV C-18, this mission also had many unique features. This is the first time PSLV is launched with a heavier satellite of 1000 kg class into an inclined planar orbit. Accordingly, significant modifications have been carried out in the PS4 stage, specifically with respect to reduced propellant loading and the re-engineering of PS4 tank to contain the sloshing, and the changes in the guidance design, and also the overall mission sequence. So with this spectacular launch, we have seen the versatility, and I am very happy to state that PSLV C-18 could be launched within 3 months, just within 3 months from the last launch, PSLV C-17, on 15th of July this year. And with this mission, 3 PSLV successful missions have been accomplished in the current financial year, and we are just ready for the next launch also. In this great occasion, I would like to express my sincere gratitude to the entire ISRO teams and the participating industries for their immense contribution towards the successful launch. And I am quite sure that the same level of cooperation and dedication will be there for the immediate forthcoming launch of PSLV C-19, an XL version of PSLV with India's first radar imaging satellite, RISAT-1. Thank you very much.
I am very happy and proud of my entire project team who have worked for years, and day and night they worked in the last few months, without which this project could not have come to this successful end. I also thank my CNES colleagues from France, and also the whole ISRO centers have contributed enormously in this mission, supported by the respective centers. The latest reports say that the Megatropics spacecraft deployment of the antennas have happened, deployment of the solar panels have been successful, and the currents and the power received is very good. The spacecraft is in good health, and I hope the spacecraft will continue to work for 5 years in orbit, looking at the entire globe. We should be ready to start analyzing the data, which is expected to come maybe in the next 2 to 3 weeks, when all the payloads will be switched on. The whole world, the scientific community is looking for this data set because of this uniqueness of this kind of data available in the whole world. Thank you all.
Just a few words to say thank you very much to all the team. Congratulations. It's a very professional launch. And you know that this program is unique because, Mr. Chairman, it's the first Indo-French satellite. It's the first, maybe, tropical orbit for your polar satellite launch vehicle. So it's not a polar satellite launch vehicle, it's a tropical satellite launch vehicle. So thank you very much for that, it's very good. And then the other point, it's also the first satellite of the constellation of GPM, Global Precipitation Mission. That's an international mission. So we all contribute to an international mission for the precipitation, for the meteorology and climatology all around the Earth. So that's very, very, very good. And I would like to congratulate all the team, the project team, and the chairman, Mr. Chairman. Without you, nothing. So that's very good of you. Thank you very much. And I hope that we will see each other, another story for other satellites. We will be together.
Yes.
Thank you very much.
Those who led the development of this versatile satellite launch vehicle are here. Mr. Veeraraghavan, Mr. Ramakrishnan, Mr. Ravindranath, and the chief of this center, who has been the chairman of the Launch Authorization Board, Mr. Dattan. They will say a few words, and then we have those who built the satellites, Dr. Alex and Mr. Kiran Kumar.
This is a momentous occasion with the PSLV confirming its tempo of success. PSLV, as Dr. Rangan said, P stands for perfect, is perfect satellite launch vehicle. Quality breeds success, and it is ISRO's commitment to quality which is responsible for this continued success. The credit goes to entire teams across the various centers and industrial partners for taking extreme care in preparation of components, subsystems up to the integrated vehicle. I also have special appreciation for the megatropic satellites and the two other student satellites, SRM-SAT and Jugno. And I join all others in congratulating the entire team and the industrial partners. Thank you.
So it's one more magnificent mission by PSLV. Of course, each mission is unique, so we say that it's a repetition of the same vehicle, but then the amount of attention we have to pay for each launch is same as first launch. And of course, this mission, we had again multiple satellites, but then the specific mission of megatropic required certain re-engineering of the upper stage, and we did have some anxiety, and it has proved that all our work has been in the right direction. And it gives us great confidence, and PSLV is growing in strength launch after launch, and it has become a perfect workhorse. I am sure we are going to undertake many more complex missions using PSLV. And I can say that I'm really proud that PSLV really symbolizes the assured access to space for India. It's a great moment for us. Thank you.
The success story of PSLV continues. But for the ISRO team, every successful mission is a very tough job. Behind the screen, the job is very tough, and every mission is unique. I take this opportunity to appreciate, acknowledge, and encourage, congratulate the effort put forward by the whole ISRO team, the industry partners, and the institutes for attaining this great success today. We are also thankful to the government for giving every support to us, the public for giving all encouragement, especially the media who brings all our achievements to the public in right time in the real spirit. We are also planning to have the one more PSLV mission by the end of this year. And as you all know that next year we will be coming up with the GSLV with the indigenous cryo stage also. The team is so busy, and I take this opportunity to see that the ISRO team will be meeting the requirements of the nation as desired. Thank you.
Team ISRO has once again demonstrated their capability, and the 20th mission of PSLV has been a tremendous success. In fact, the orbits what we have got is excellent. It is only 2 kilometers off from what is decided, and the type of amount of effort what is put by the various teams and the partners, and also the foreign colleagues who had been a part and parcel of this mission, particularly the French and the Luxembourg. So it is really a very unique opportunity for ISRO to demonstrate that we are now reached the international arena also in global cooperation. In fact, I want to congratulate everyone who has contributed to this excellent mission, and also I think that ISRO has to again rededicate ourselves to realize such missions in future. Thank you.
Today is a great day. The satellite just now launched is the 5th satellite developed by ISRO Satellite Center in this year. So let me first of all congratulate the entire satellite team spread across all the ISRO centers who worked very hard to make this achievement possible. Let me also congratulate the teams who made the small satellite, the university satellite. First the SRM satellite. The professors are here, the management, senior management people are here. Dr. Pachimuthu, Ravichandar, Satyanarayana, Narayan Rao, all are here, and all the students worked under their direction. Let me congratulate each one of them for this wonderful development of a small satellite. They are also equally complex satellites. Let me also congratulate Professor Dande, Professor Vyas, and all the students of IIT Kanpur who worked day and night to make the satellite possible. The IGNU satellite is a very unique satellite. They worked very hard. They had a very difficult time. Even the last day they were trying hard to make it possible. Let me congratulate each one of them for this wonderful contribution. Thank you very much.
Let me take this opportunity to congratulate the entire satellite launch vehicle team. They have put the satellite up in space, and now our work starts. Now we have to receive the payload data and then start making use of it. And this particular data has already been pointed out, is being looked over world over because it's a constellation for GPM. And in this context, I would also like to congratulate the French team because we have worked together for building a payload which is fairly unique in the sense probably this is for the first time two international space agencies have created one payload where they have worked together for making a single instrument. So far, I don't think there is a parallel for that. We look forward to receiving the data and providing it for the users. Thank you.
On behalf of the ISRO family, let me express our gratitude to the Honorable Prime Minister, the Minister in charge of space, for all the support, all the encouragements that he has given, especially in our difficult moments. This mission is the beginning of a new phase of cooperation in space between India and France. And what this cooperation has given to the world is a satellite which is going to give us a lot of information, knowledge about the tropical region and how does it propagate to the rest of the world. It's a truly a global mission, a contribution from our side. We have a major task ahead of us, that is the development and perfection of the indigenous cryogenic stage. We are making good progress, and we are planning to have the next flight of GSLV with the indigenous cryogenic engine and stage in the second quarter of 2012. And before that, we plan to have 2 more missions of PSLV, one for launching India's first microwave remote sensing satellite, and then another joint mission of India and France to look at the oceans. Let me thank every one of you watching this mission, the live telecast, and for all the support that you have given to us. The friends from the media, the people of the country, and all in government who facilitated what we have seen today. And we promise we will sustain the legacy that our founders and our leaders over the last 50 years have developed. Thank you very much.